want to understand Bayes' rule. Now for this, let's recall the multiplicative rule. Now, if we recall, the multiplicative rule is that you can find probability of A intersection B as probability of A given B into probability of B. And you can also find probability of A intersection B. This is something we already discussed, that the multiplicative rule says you can find probability of A intersection B in both. And they both give you the same answer, right? So from here, because probability of A intersection B is equal to probability of A given B into probability of B, so they're equal, right? Because probability of A intersection B is equal to both of them, so we can equate them, right? Because we know we can find probability of A intersection B using both of these ways, and they both will give the same answer, so I can just equate them. From here, I can make probability of A given B the subject, so this is probability of A given B is equal to probability of B given A into probability of A divided by probability of B. Now, this is what we call the simple Bayes rule. Right, this is the simple Bayes rule. Right, this is the simple Bayes rule. Now, let's just so we saw, okay, we can, the simple Bayes rule is that probability, probability B is probability probability A given B is probability B given A into probability A divided by probability B. This is simple Bayes rule. Now, using law of total probability, now using law of total probability or probability of B, which is in the denominator, right? This. So then we can write this as probability A given B is probability B given A into probability. We know the law of total probability allows us to find unconditional probability, in this case probability B, by conditioning on mutually exclusive and collectively exhaustive events. In this case, we will condition on A and A complement, because an event and its complement are mutually exclusive and collectively exhaustive. So we can write probability of B by conditioning on A and A complement, because both of them are mutually exclusive and collectively exhaustive. Right, so we can find probability A given B using, so basically once here, for probability of B, we can use the law of total probability. We're finding this unconditional probability of B, by conditioning on the mutually exclusive and collectively exhaustive events. A and A complement, because an event and its complement are always mutually exclusive and collectively exhaustive. This is the full standard form of Bayes rule, right? Where you just use the total or probability in the denominator. So now, where do we use Bayes rule? What is the application? Now, we use Bayes rule when you're given one form of conditional probability. So you're given one form of conditional probability, such as probability B given A. So you're given this form of conditional probability, and you want to find its exact opposite form. Its exact and you want to find its exact opposite form of conditional probability, probability A given B. Right, so basically use a Bayes rule when you give one form of conditional probability, say probability B given A, and you want to find its exact opposite form, probability A given B. Because like you said, the formula is probability A given B is probability B given A into probability of A divided by probability of B. And here we just apply the rule for probability. So we're given one form, and you want to find the exact opposite form. So that's where you use Bayes rule. Let's look at an example. Say D is the event the person has a disease. And T plus is the event the test is positive. And say you're given this piece of information. Okay, the probability that the test is positive given the person has disease is 0.95. The probability the test is positive given the person does not have disease, T complement is 0.01, and the probability the person has disease is 0.05. We have these two events, we're given these probabilities and ask us to find probability of disease given test is positive. So we want to find this probability of disease given test is positive. Now the idea over here is that we have probability test is positive given disease. So we have this form of conditional probability and want to find its exact opposite. We have probability test is positive given D and want to find its exact opposite, which is probability of D given test is positive. So we use Bayes rule. Right, so here we will apply Bayes rule because we're given one form of conditional probability. Probability test is positive given disease and you want to find its exact opposite, right? So we'll apply Bayes rule. So this will be probability D given test is positive is probability test is positive given D into probability of D divided by probability test is positive. And the denominator is going to come from the total of probability. Denominator from total of probability. From total of probability, where we will find this unconditional probability by conditioning a mutually exclusive and collectively exhaustive events, in this case D and D complement, right? So this will essentially become, if I just clear this, so we said using Bayes rule, we can write probability of D given test is positive is probability of test is positive given disease into probability of disease divided by probability test is positive, right? Which we'll find using total of probability, right? So this comes from total of probability. So from total law of probability, this can be written as probability test is probability test is positive given disease into probability of disease plus probability test is positive given no disease into probability no disease, right? So we're finding this unconditional probability. The probability test is positive by conditioning on these mutually exclusive and collectively exhaustive events, which is D and D complement. Now we were already told the probability the test is positive given disease is 0.95. The probability of disease was 0.05. Now, probability test is positive given disease is 0.95, probability of disease is 0.05. And you are told this also, probability test is positive given no disease is 0.01 into probability of no disease, which is 1 minus probability of disease, right? Because probability of an event is probability of an event is 1 minus probability not, right? We know the complementary. And from here, we can just solve for the probability of disease given test is positive. So the key thing to remember here is that we use Bayes rule when you're given one form of conditional probability and you want to find its exact opposite form. Like in this case, you were given probability test is positive given disease and you wanted to find its exact opposite form, probability of disease given test is positive.